Okay, so in this video we're going to be talking about percentages.
There's this argument in mathematics. Was maths discovered or invented? Some parts of maths discovered was clearly there. In this case, the counting numbers, in the sense that you can count things. For example, like 1 box, 2 box, 3 box, 4 box, 1 sheep, 2 sheep, 3 sheep, 4 sheep. That was discovered that you can actually share those numbers from one thing to another. The mathematical idea there is that you can use 3 to count 3 sheep and also to count 3 dogs. And then we went on from there and we invented the number 3, which doesn't actually exist, by looking at these similarities. But in this case, we're going to look at something that was even more obviously invented, which is the percentage. You can argue that numbers can be represented in real life, but percentages are definitely not real life things. It's just a way of representing something that is in real life. So let's have a look at an example of a percentage. So we see percentages a lot in real life, and the reason we use percentages a lot is it's a representation of numbers that is really easy for non-mathematical people to understand because it uses whole numbers. So instead of saying a half, for example, something's half price, half would be, if you do 1 divided by 2, you get 0.5, so that would be the same. You would instead give a whole number. These two are not whole numbers. You'd instead give a whole number, which is 50, or like 50%. And all of these numbers are the same. They represent the same thing, but they're like different representations of it. This says that a half is 1 divided by 2. This says a half is 0.5, and this says a half is 50%. And all of these are right. There's different representations of the same thing. Now, from going from here to here, these two are basically identical. So if I give you something like 0.32, then it's super easy to turn it into a percentage. It's just 32%. All you have to do is you take the decimal point and you shift it 2 along. So you multiply by 100, and then you add this percentage symbol. So if we had something more complicated like 0.25, then it would go 2.5%. And yes, you can definitely use points in percentages as well. But the idea is this number would be hard for a person to make sense of. What does 0.125 mean? It's not clear. But 12.5%, when we think of percentage, what we're thinking of is out of 100. So if we want to say, 12% of people are left-handed, I think it's about 10%. Say 12.5% of people are left-handed. Well, we know if there was a room of 100 people, just over 12 of them would be left-handed. Percentages are really easy to make sense of, whereas these decimals are not so easy to make sense of, and fractions are even harder. For example, if I gave you this and asked you to work out what the fraction for this was, you wouldn't be able to tell me right away, right? But you can make sense of what it means even without knowing the fraction. And the fraction happens to be 1/8. That's not really important. Instead of saying 12 out of 100, I said 1 person out of 8. I think maybe the out of 100 thing would be easier to understand, because it's just, maybe it's just because I'm so used to seeing out of 100. But out of 8, our fingers, they were designed to count up to 10. So everything we see is in lots of 10, and 8 is not in lots of 10s.
Okay, so where do we see percentages?
For example, when we have a battery, so a battery in our phone, and when it's out of charge, we see it as 0%, and when it's at maximum charge, we see it at 100%. Well, so you might ask, do percentages only go down to 0 and only up to 100? Yes, kind of. Not always, but usually it does. In the sense that something is 0%, it means that the battery is empty. Can we have negative percentages? Not in the case of a battery. Can we have more than 100% charge? Again, I don't know if you watched one of the Iron Man movies where Tony Stark is hit by some lightning and he gets up to 140-something% charge. But in real life, it does. If you go over 100%, you'll damage your battery, and it just usually doesn't work. But could you technically go above 100%? Yes, you can. For example, one way you can go above 100% is in something we'll look at later, which is percentage increase, which we'll do in another video, where we look at percentages as the amount of change goes from what it is normally, and it increases by some percentage of itself. and we'll look at that later. And in this case, it can
Go to as high a percentage as you want.
And if increase is positive, you can think of decrease as negative, and we'll cover that as well. Okay, so that's it for this video. Thanks for watching.